Hello, this is Dr. Wyatt. I'm going to address some problems from homework number 8 that were not addressed in the regular Zoom session, and we'll just get started. First one is find the probability that z is greater than, this is my number 2, that. So z tells us it's a standard normal curve, and grab that, and then I'm looking for z is greater than negative 2.99. Now this is negative almost 3, essentially 3 standard deviations, and z is greater than that, so I'm looking for the area to the right of that curve. If I'm using a calculator, I'm going to put my lower limit as negative 2.99. My upper limit is infinity, so use infinity if you're using an 89, or a really, really large number like this. And then our mean is 0, and our standard deviation is 1. If you are using either one of the older TI-83s where it doesn't give a lower and upper limit, or Excel, it's only going to provide you with, you're going to put in this 2999, and it's only going to provide you with this lower limit right here. So in order to find the right tail that you're looking for, put in that negative 2.99, and get this number, and then take 1 minus the answer that you got. So in this case, when I do that, rounded to 4 decimal places, I would get 0.9986, and that passes the smell test because 3 standard deviations away from the mean is essentially all the data, and this is essentially all the data. All right, the next one is the probability that we are between negative 0.83 and negative 0.3. Again, you have a normal curve. We know it's a standard normal curve because this variable is z. Right here is 0. Negative 0.83 on our number line is down here. If that's 1, I mean, it's maybe not exactly to scale, negative 1. And negative 0.3, somewhere here then. This is about a half a standard deviation of data in between those. Now, if you are using something like a TI that only gives the left or Excel, okay, if you're using one that asks for a lower limit and an upper limit, then you can just plug in your lower limit as negative 0.83 or in 0.3, and then like on those it might ask for center or whatever those types of things are. Mean is 0, standard deviation is 1, and it will give you the answer. If you're looking at one that only gives you the left tail, you're going to do this twice. First, you're going to find the left tail from the 0.3, right? From the negative 0.3. So you type in negative 0.3, and you get a left tail. So I'll do this on Excel real quick. In order to do that, I would type the equal sign, norm dot dist, x is negative 0.3, mean is 0, standard deviation is 1, cumulative is true, and I would get this blue area right here at 0.3820, oh, excuse me, let's try that again. This blue area would be 0.382089. Now I'm going to do the same thing again, but this time I'm going to put in negative 0.83. That's going to give me this green area right here. So I put in that, and I again type equals norm distribution. My x, or is negative 0.83. Mean is 0, standard deviation is 1, cumulative is true. Hit enter, and the green area right here is 0.203269. Now I'm going to take the difference of those two, and that's going to give me that black shaded area that I actually want, the area in between those two. So I take the difference. This is always going to be easiest if you draw a picture. you don't draw a picture, you might have a hard time deciding whether you need to subtract from one, subtract from each other, and so on and so on. So the final answer is 0.78819 to 4 decimal places, 0.7188. Right? All right, taking a look at question number 4. Question 4 is the same problem that we just did, but this time it just is using words. It reads about what percent. Whenever they're asking for a percent, they're looking for a CDF or norm.dist. Right? This is what percent follows the standard normal curve between these two numbers. Right? And then just says to round to 2 places. So when they're looking at a percent, they're looking for area cut under the curve. And when they give you a percent, then they're actually looking for the cutoff numbers. That's when you use the inverse normal. So this is just like that last one. That's number 4. Number 5 I did on the Zoom session, so I recommend that you take a look at that. And number 6 says, suppose your manager indicates that a normally distributed data set that you are analyzing, your company wants the points between z is negative 1.2 and 1.2 standard deviations away from the mean. What percent of the data points? This is exactly the same as percent number 4, right? If I were doing this on a computer like the 83 or the new 84, I'll just talk about that one real quick since I have one of those right here. If you are using an 84 plus for this, I would just go to distributions, second vars, choose normal CDF, which is number 2. It asks for a lower limit. I would choose negative 1.2. Upper limit, I would choose 1.2. Mean is 0, standard deviation 1. Paste and hit enter. And this would be 76.9896. Now, if you are rounding this to 2 decimal places, round your percent to 2 decimal places. Do not include the percent sign in your answer box. So you're going to put that there. This would be 76.99%. That's doesn't want the percent, but that's what it's looking for. So make sure you're entering your data correctly. Now, were I to do this on Excel, I would first have to find this area, left tail, it's the bigger area, then this area, right tail, and then subtract the 2 would give me the area that I wanted. Taking a look at question 8. Question 8 says a particular fruit's weights are normally distributed with a mean, with a mean of 634 grams and a standard deviation of 9 grams. You pick one fruit at random. What is the probability it will weigh between 618, so we have a mean at 634, and a standard deviation of 9. Weigh between 618 and 624. So you're looking for that area right there. Using the TI 89, all I need to do, or excuse me, 84, again hit second vars, which is distribution, number 2 CDF, and it asked me for lower limit, I'd put 618. Upper limit, I'd put 634. The mean I need to change now, I'm sorry, upper limit is 624 on this problem. The mean is 634, and the standard deviation is 9. Paste that, hit enter, and you should get your answer. Which is 0.09554, rounding to 4 places would be this right here. All right. That would be the probability. Okay, now we're looking at question 9, and 9 kind of flips the tables for us because it gives us a mean weight of these fruits again that are 777 grams with the standard deviation of 9 grams. Now it's asking, what's the heaviest 10%? So they've given us a percentage here. They're looking for this cutoff. So this is going to be an inverse problem because they gave us a percent or are looking for a cutoff. If I do that on Excel, for example, I'm going to write norm inverse equals norm inverse. It asks for a probability. Now Excel always is working from the left tail. So it's going to ask for this probability to get that upper cutoff. And if this is the top 10%, that number is the same as the bottom 90%. So I'm going to go in probability 0.9. Mean is 777. Standard deviation is 9. Cumulative, it doesn't ask for that. It's always cumulative. There we go. And this number would be 788.534 with my numbers. Okay. If I was using the calculator, I would be choosing inverse normal under distributions. Okay. Question 11 was done on the Zoom session, so I would recommend you take a look at that. The next few questions are very similar in nature, so I'm going to jump up to 14 and 15, which is a little bit different. It says it takes time for me to wash the dishes is uniformly between 11 and 21 minutes. So 11 and 21 minutes. Right there. What is the probability that washing the dishes tonight will take between 17 and 19 minutes? First of all, you need to know that in this rectangle, this has an area of 1. So if this is 10, from 21 to 11, then this is 1/10. That's the height of this. And now if I draw a little rectangle between 17 and 19, and I'm looking for that area, that would be 2 on the length here from 17 to 19 times 1/10. So the answer would be 2/10 or 1/5 or 20%. Okay, so problem number 15, you have this here, which goes from 0 to 2. And then since this whole area has to be 1, this has to be 1/2 because that's it. In general, if this is A and this is B, then the height here is 1 over B minus A. Okay. So it says, what's the probability that X is at least 1.64? So 1.64 or bigger. So to find that, I'm going to take this distance right here. So 2 minus 1.64. Take a second to calculate that. It's 0.36 times 1/2. Taking 0.36 to find the area, that's your length times your width, times 1/2. And you get 0.18. So that would be your probability there. I'm going to let you try 16 on your own because it's very similar to 15. I'll jump down to 24 and 25. It says the time it takes to perform a task in a continuous uniform distribution, okay, again, we're working with the uniform distribution, is between 43 and 57 minutes. It looks like this. Like I said, so 57 minus 43 is 14. So this height is 1 over 14. Together, when you multiply the area of this rectangle becomes 1. All right? Now, I want to find the area of the rectangle. That is 47.5 up to 50. All right? You know this length, or this height here, and you just need to figure out what this length is. I'll let you do that with your numbers. Okay, I hope this video is helpful. Feel free to email me if you have additional questions. Thanks so much.